Okay, let's look at this question, okay? This is a table. The T is the hours at 0 hour, 1 hour, 3, 6, and 8 hours. At the corresponding time, the passenger on board. That's why I said the number of the passenger who have boarded a ship is modeled by the differentiable function. Be careful, this function is differentiable function, okay? Where T is the number of hours since the boarding began, and values of PT for the selected value of T are given on the table above. This one means, like, for example, 1 hour after the boarding, you have 35 passengers there. 8 hours boarding, you have 728, okay? Now, let's look at A. They said, according to the model, what is the average rate of which passenger bottom the ship in passenger per hour over the interval, time interval of 1 to 8. So when we do this one, we simply use the formula of average rate of change, right? The average rate, so average rate equals what? Equals to P8 minus P0 over 8 minus 0, right? That's the definition of average rate. So total from the passenger from the 0 change to 728, right? So this is 728 minus 0 over 8 minus 0, just 8. So we can do the calculation now, use the calculator. So we can find out 728 divided by 8, you will get what? 91. Right? You got this one now. So that's the average rate for the passenger in between 1 to, oh, wait a minute. They said from 1 to 8, my bad here. So from 1 to 8 instead of from 0 to 8, right? So that means here should be changed to, here will be changed to 1. My bad here. So that means here you need to change it to T equals 1, that's 35 here, 35, okay? And still, but right now from 1 to 8, that's 7 hours past. So you got to change this one to 7. So this one should be 8 minus 1. That's just 7. Okay? Let's redo the calculation now here. So you're going to have 728 minus 35. You got this one and divided by 7. We got 99. So it means average, every hour you have 99 passengers on board, okay? Now write the P, they said write the P prime derivative at the x equals 4.5 as a limit of the difference of the quotient, right? Use the data in the table to find this one, okay? So when you do this one, you go like this. You can go by this one derivative of 4.5 will be what? Limits, right? X approach to 4.5. You can get what? Px minus P 4.5 divided by x minus 4.5, like that. So this is a general definition about derivatives. Or you can write like this. The other way you can write like this is this. You can say P derivative 4.5 equals what? Equals limits h approaches 0. P 4.5 add by h minus P 4.5 divided by h, like this. Either way is fine. Either this one is fine or this is fine, okay? Now, So you find the difference quotient. We did find the limits of different difference quotient. We found that already. And then use the data table, approximate. So if you want to approximate, right? So what we're gonna do is this. We can make this one equals to, so we got put it here, okay? So P derivative 4.5. So approximate 4.5 is in between 3 and 6, right? So we can go by what? The value, we can go like this. We can go P 600 minus a P 2.4 or 204, right? This one minus this one, because this two value corresponding to time T hours and 3 hours, and 4.5 in between. So we find the average. So this one divided by 6 minus what? 6 minus 3. Oh, actually, here's this. Here should be not 600, so should it be P, right? Should it be P6 minus a P3, like this, over 600. That's the average rate of change, right? Average rate from 3 to 6, okay? That's 4.5 in between. So we can use this one to estimate that. So you can what? P6 will be what? 600. Minus P3 will be 204. Divided by 6 minus 3, right? So we can get this one as here, 600 minus 204, you got this one, divided by 3, you got this one. So you can get a what? 132. That's for the B, okay? Let's go to C now. Must there be a time 3, T from between 3 to 6, T. You have a PT equals that. Be careful here. We know here, let me erase this part first here. This one, eh? So we know X equals to 6, T equals 6. The passenger is 600. And the 3 is 3 hours later is 204 passengers. So, and also this function, be careful, PT function is what? Differentiable. If it's differentiable, guaranteed, this one is what? Continuous. So we're going to use what? Mean value theorem for continuous, okay? We use that. So the mean value theorem for continuous says that if this function continues, you have, you see here, just like this graph, I just illustrate this one first, okay? If T equals 3, you have what, how many? The passenger there is a 204, right? That's here, 204. And if the T equals 6, and the passenger number will be what, 600, huh? So 600. So the passenger number from here to here, right? No matter what the route, since this is continuous, no hole, guaranteed they were passing through what point? They were passing through the point somewhere to 500. So there is one value of the time there, at least there, time there, right? So they ask you, must there be a T? This is the T, which PT will be 500. PT is 500 here. So that's mean value theorem for continuous. So yes, the answer is yes. Okay, because of the mean value theorem for continuous. All right, so let's go to D now here. The total number of gallons of water used by the passengers on the ship. is modeled by the function g of this. This is g function here. T in between 0 and 8, where t is the number of hours since boarding began. They ask you to find the derivative of the the rate of the passenger using the water in gallons per hour at the time t was 4 hours. So what you can do is this, you do derivative, right? So you're looking for g derivative of the t, but t must be equal to 4, right? So you do derivative of this function here, right? Before you do that, you may rewrite the gt as what? 120 and the t to what? 3/2 power, huh? Because this one is t, and this square root t is t half power. This is 1 power. So add together, that's why you got the 3/2 power, okay? So when you do derivative of that, what are you gonna do? You simply go by 120 constant, leave there. Put the power exponent in front, and then have t, 3/2 minus 1, just half. And then plug in t equals 4 now, right? So you're gonna have what? This one cancels 60. Okay, we'll just do the calculations better way, okay? So you go like this one here, 120 times by 3 divided by 2. You will be what? 180. So this is 180 times by t half power, means square root. T equals 4. This is 4 like this. Square root of 4 is 2. So that means what? 360, right? Gallons per hour. This answer here. Okay? So that's what we did about this question, A, B, C, D. Here, be careful, here's this. They give you the table, this is a differentiable function. So that means what? This is continuous. So when you do the C here, you can use what? Mean value theorem. Okay, just be careful of that. All right, so if you have any questions, please let me know. Thank you. Bye-bye.